Now guys, coming to question number 3 of JEE Mains 2020. The paper was held on 8th Jan 2020, shift 1. The question says, they have given a figure on the question. The figure is volume versus temperature graph, and this is a cyclic process which they have given, and we have to choose corresponding option which matches with this question. All the 4 options are based on pressure versus volume graph. So let's try to make a graph which corresponds to volume versus temperature graph. Now let's see for the graph x to y. The graph which is going from x to y, it shows that volume and temperature both are directly proportional to each other. So we know very well that if volume is directly proportional to temperature, it says from the expression PV is directly proportional to T, this thing says that P is nothing but constant. That means pressure will be constant. Here, while the graph is going up, the volume is increasing. That means since the volume is increasing, I shall say the volume, yes, the volume increases, but at the same time the pressure will remain same. Let me assume this is a value of pressure. At this particular value the volume is increasing but the pressure is remaining same. This is the first graph from x to y. Now let's proceed with the next graph, y to z. You'll see that the volume is constant in this case and the temperature is decreasing from y to z. So if volume from PV is proportional to T, if volume is constant, we are pretty clear that pressure is directly proportional to temperature when volume is constant. That means this can be represented as volume should be constant. That means if this is the value of volume, this value should be constant. Now here from y to z, since the temperature is decreasing, if the temperature is decreasing, the pressure is also supposed to decrease, which means the pressure is supposed to decrease. So the graph in PV graph, it comes like this. This is y to z. These are the directions. Now if you will see from z to x, you can see that the temperature is maintained constant and the volume is decreased. Here, when PV is proportional to T, if temperature is maintained constant, I shall say that P is inversely proportional to V when temperature is maintained constant. So here, if I'm seeing that the volume is decreased, here also volume will decrease. But since pressure and volume both are inversely proportional to each other, with the decrease in volume, the pressure shall increase. So the curve goes like this, and this is your option number 1, or maybe option number A. Now dear students, let's try to understand what is the solution for the 4th problem. In this problem, they have given a shape, okay? You must understand that this shape is removed from a whole rectangle. When this particular shape is removed, you can see an inverted L, and you are expected to find the center of mass of this inverted L. Now since this particular shape is not a standard shape, what you are expected to do for the solution is you are expected to divide this irregular shape to 2 regular shapes. So these 2 are rectangles. Now how do we find the center of mass of the system? Consider this is one system, this is one mass, this is another mass, and mark the centers of both the masses. This is the center of first mass, let me call this mass as M1. This is the second center of second mass, let me call this mass as M2. Shall call this as M1, M2. Now you guys are pretty aware about the formula of center of mass, that is M1 x1 plus M2 x2 upon M1 plus M2 it is. Now how do we determine the formula? How do we apply the formula over here? Let's see. Couple of things you need to remember. You know that surface density is equal to mass upon area. That means I shall conclude that mass is equal to surface density multiplied by area. These things you must remember. Now let's try to apply. Before applying, we must mark the coordinates of the points of the centers of the masses which we have assumed. Since this is the origin, they have already given the coordinates of the edges in the question. From these coordinates, we can understand that the length the length of this rectangle is from this point to this point. You can see the y coordinate and figure it out that this particular length is 2 unit, and this particular length will be 1 unit. From the x coordinates we can figure out these dimensions, and from the y coordinate, if this much is 2 and the total length is 3, that means this particular length will be 1. And here you can see the x coordinate changes from 0 to 2. That means the total length will be equal to 2. Okay, so with the help of these dimensions, let's try to figure out how much is the center of mass of this shape. The formula says XCM. First we'll find x coordinate, then we'll find y coordinate. XCM is equal to m1 x1 plus m2 x2 upon m1 plus m2. Now instead of m, I shall substitute sigma into a1 x1 plus sigma into a2 x2 upon sigma multiplied by a1 plus a2. You can take sigma common and cancel them. Now let's substitute a1. a1 is the first area, a2 will be the second area. First area is nothing but, I shall write the value of first area. a1 can be written as 2 multiplied by 1, and that will be equal to 2. Similarly, a2 can be written as again 2 multiplied by 1. Oh, fortunately, a1 and a2 both are same, both are 2. So a1 can be written as 2 multiplied by x1. So the x coordinate of the first mass, what will be the x coordinate and y coordinate of these two masses? Let us try to plot them. Since this is on the center, from origin the total length is 1, that means the center comes at 0.5. so the x coordinate of the first mass is 0.5, and our y coordinate, since total length is 2, the center comes in the center, that means y coordinate will be equal to 1. Now about m2, again, if this is y-axis, from y-axis how much is the distance of m2, center m2? Let's see, the total length is 2, the half of 2 will be equal to 1, that means x coordinate will be equal to 1. And about y coordinate, from origin this much of length we have to consider, we cannot skip them, plus half of the total 1. 1's half is 0.5, 0.5 plus 2 is nothing but 2.5. Now this is x1, this is y1, this is x2, this is y2. Let's try to proceed further. Now instead of x1 I shall substitute 0.5 plus, instead of a2 we have already found that the a2 is 2, and instead of x2 I shall substitute 1 upon a1 plus a2, that is 2 plus 2. The calculation will give me 2 into 0.5 is 1 plus 2 into 1 is 2 upon 2 plus 2 is 4. In short, it is 3 by 4. That means 0.75. That will be your XCM. You've got your x coordinate. After finding your x coordinate, the next job is to find your y coordinate. Now how to find your y coordinate? Again, same figure you have to consider. Considering same figure, I'll be finding the y coordinate adjacent to the figure. YCM will be equal to m1 y1 plus m2 y2 upon m1 plus m2. Again, instead of mass I'll write sigma into a1 sigma times a1 y1 plus a2 y2 upon sigma times a1 plus sigma times, sigma is taken common, therefore it's only a2. Sigma gets cancelled. Instead of a1 I'll write, I've already found the values for a1 and a2. Instead of a1 I'll write 2 multiplied by, instead of y1, so y1 is nothing but 1. Instead of y1 I'll write 1. Instead of a2 I'll write again 2 multiplied by, instead of y2 I'll write 2.5 upon a1 and a2, they are 2 plus 2. Now in this case 2 multiplied by 1 is 2 plus 2 multiplied by 2.5 is 5 upon 2 plus 2 is 4. That will give me 7 by 4. 7 by 4 can be expressed as 1.75. So your YCM is 1.75 unit and XCM is 0.75 unit. That's your center of mass. Hello guys, let us try to understand what is the fifth question. In fifth question, they have given you four graphs, four options. Okay, in all these graphs, tau represents the relaxation time of gas molecules and T represents the temperature. In the first graph, they have said that tau is directly proportional to 1 by root of T. Second graph, tau is directly proportional to T. In the third graph, tau is inversely proportional to 1 by T. In the fourth graph, tau is directly proportional to root of T. We have to find which one of the graph is correct graph. Now how to find? It's a very simple solution. Now first of all, what is tau basically? As I've already told you, tau is relaxation time. Relaxation time is the time taken by a gas molecule between successive collisions. Okay. Now basically any time can be defined as distance upon speed. Okay. And you guys are very well aware that distance between successive collision is expressed as mean free path and speed is v. Now here you must know that the mean free path is expressed as 1 upon root of 2 by d square multiplied by n, where n is number of electrons per unit volume. Now all the terminologies here are constants and neither of them are connected to the temperature. That means the mean free path is not going to give you your answer. The whole mean free path is going to behave as constant. In this case, speaking about V, we are very well aware that V is directly proportional to root of temperature. This is already proved in kinetic theory of gas. Now when you substitute it over here, compare these two expressions. Since it is constant, I shall say that tau is inversely proportional to V, and I shall say that V is directly proportional to root of T. Combining these two terms, I shall conclude that tau is inversely proportional to root of T, or I can also say that tau is directly proportional to 1 by root of T. Now comparing all four graphs, speaking about root of T, we know that tau is inversely proportional to root of T. Here they have shown directly proportional, so this is not the correct option. They have T, not root of T. Let us ignore them. Coming over here, we know that tau is directly proportional to 1 by root of T. Yes, tau is directly proportional to 1 by root of T. That means this option, the first option, is our correct answer.